This is the circuit diagram of the cooling water system of our unit 3. Here you can see that a cooling water system consists of condenser, 3 CW pumps are there, one Forebay is there, one this is CT or cooling tower. Our tower system, huge quantity of steam is required to move the turbines, and the steam is in turn cooled in the condenser, and for that a huge amount of cooling water is required. The tune of around 20,000 ton per hour circulation is required, and this water is who supplies this water? The Forebay. The Forebay supplies this water, and we have 3 CW pumps. One pump run at a time, and these pumps give water to the condenser where it cools the steam, and in the process it gets heated, and this water is again fed back into the cooling towers where we have fans, and with these fans the water gets cooled, and some portion of the water is evaporated into the atmosphere, and water from the CT basin is again coming into the Forebay. This is the real picture of the Forebay circuit. Now, for protection of the assets, to protect the system from corrosion and scaling, we have to make this water appropriate, and for that the condition monitoring of the cooling water is extremely essential. Now, in our system, Unit 3, the system is maintained not in a manual but in an automatic way. For that, a sample from this CW pump discharge is taken into the system. Here you can see a sample from this CW pump discharge line is taken into a system which is known as a 3D tracer system. This is the 3D tracer, and for that we have different probes which actually measures the pH value, the conductivity of the cooling water, and the ORP value, and like this. Now this 3D tracer is also connected to different systems, different core systems. Now the pH probe gives feedbacks to the 3D system, the conductivity probe gives feedback to the 3D system, the ORP probe in a similar fashion gives feedback to the 3D tracer system, and the 3D tracer system is again connected to the dosing system, sulfuric acid dosing system, and the hypochlorite dosing system. Also, it gives feedbacks to the unit control room DCS, and not only that, it also is connected through internet or wireless to the system assurance center located very distance, where overlooks the system as a whole, and whose job is to, and it can through IoT or internet on things, it gives command to the dosing system pumps, and also it gives different SMS mails to the end user like us and the people at the field who operates the system. Now I can just explain how it controls the pH of the system. Suppose this pH probe measures the pH at 7.1, 7.8, sorry, 7.8, and it can maintain pH from 7.8 to the band 8.1. Now, whenever the pH of the system reaches 8.1, it gives a signal to the 3D tracer that the pH is 8.1. The 3D tracer is programmed in such a way that it gives signals to the dosing pump, one of the dosing pump which is in service. One is in service and the other is standby. So it gives signals to the pump to run. Now when it runs, the pH of the system will drop from 8.1 to 8 to 7.9. And when it comes 7.9, the pH is programmed in such a way it gives signal to the pump to stop. In this way, it can control the pH of the CW system. Another function is that it has also programmed to give a relay timeout to the pumps whenever there is any discrepancy in the dosing system or in the health of the pH probe. If the pH, suppose the pH probe is not showing good enough values or it is not correctly showing values, then if this 7.8 is not actually 7.8 but it is actually 7.2 or 7.3, then the system will be corroded. So in that case, the 3D tracer is designed or programmed in such a way that overdosing of acid can be prevented. Whenever it shows that after dosing for a certain time the pump does not stop, the pump does not signal of the low pH does not come, then automatically it can give a signal to the pump to stop. And also a message to the system serial center goes to the end user. In this fashion, it can control the pH of the system. Similarly, for conductivity, the conductivity values goes to the 3D tracer system, and from there it can go to our DCS. In DCS we have two values, a band, or rather a band where this valve is conductivity. This DCS we have programmed for operating the conductivity auto conductivity valve.